Hey guys, welcome to a new video. In today's video, we're going to look at a Leetcode problem, and the problem's name is out of boundary paths. So in this question, we are given a m.n.N grid with a ball. So initially the ball is at the position start row, start column, which are given as input parameters. You are allowed to move the ball to one of the four adjacent cells in the grid. And possibly when you're doing that move, the ball might go out of the grid and you can apply at most max moves to the ball. And this is also given as input to us. So the inputs given are m.n, max move and start row and start column. And our task is to return the number of paths to move the ball out of the grid boundary. And since the number of paths is going to be very large, you have to return with its modulo, that is 10 power 9 plus 7. So you have to apply modulo before returning the output. Now let's take a look at these examples and see how we can form our output. So let's take the example 1. So m is equal to 2 and n is equal to 2, representing the number of rows and columns. And the maximum number of moves we can do is 2, and the ball is at the top left position 0, 0. So the ball is here. So this is 0, 1, this is 0, 1, and the size is 2 by 2. And max moves we can do is 2. And we have to count the number of ways, which is initially 0. So initially count is equal to 0. So first, to go out of bounds, we can kick it out to the top. So now count is equal to 1. To make it go out of bounds, we can kick it to the left and it is out of bounds. And if we go to the right, it is still in position, so count is not changed. And if it goes down, it is still inside the grid, so count will not change. So if you are doing one move, we are getting two possibilities of kicking the ball out. Now if we are getting two moves, we can kick the ball once here, and the ball is here, and this is one move. And from here, if we kick it out, it is one more move. So total moves are 2, and that is one way of kicking it out. Now let's see another way. So if we kick it here, ball is here. And from here, if we kick the ball to the top, it goes out of bounds. So this is one kick and this is one kick. Entire green path is one way of kicking the ball out. If you kick it down, the ball is here. And from here, you can kick it down again. So this is one kick and this is one kick. Total kicks are 2. And that is one way of kicking the ball out. And one more way is, if you kick the ball here, the ball is here. And from here, you can kick it to the left boundary. So this is one way and this is one kick. So that is one way. Now let's explore other ways of kicking the ball twice. So if you kick here, ball is here, and from here you can kick to here and the ball is still in the range. So this is not one possible way. And if you kick to the left, we already discovered that, and no matter again from here if you kick, the ball is still out. So here in one path only it's outside, so you can't consider this. And same with here, when you kick it out once, it is out. From here, if you kick it any other way, it is still out. We shouldn't consider this because here only it is still out. So what can you observe here? For every position, you are kicking the ball in 4 directions. That is top, right, down and left. And what is top? It is I minus 1, j. If you consider these as I and this as j, I minus 1, you're going to the top and j is constant. If you're going to the right, it is I is constant, you are in the same row, but j is plus 1. Here I is also constant. You're going to the left, so j minus 1, and here I plus 1 because you're going down, and j will be the same because you are in the same column. So you have to check for 4 directions in every possible path. So this is giving you a sign of using recursion. And one more thing, so if you observe here, observe this yellow path and this black line. The first kick is same for both of them, and from here yellow kick is going down and black kick is going to the left. So for example, if you calculated the path for the yellow kick, you don't have to calculate this path again. You don't have to calculate this value again because you already calculated it here. So these are repeated values. There will be a lot of repeated values. So to avoid that, you have to implement memoization, which uses a DP array. The size of the memoization table is going to depend on the number of changing parameters in the recursive calls. In the recursive calls, you have to change the row and column. So those are 2 recursive calls, and in each recursive call, if it is going out of bounds, increment the count and make the recursive call. So every recursive call will have 3 changing parameters. So you're using a 3D DP array to store the calculated values so that you can avoid repeated calculations. And you have to define the exit condition for the recursive call. In the recursive call, the exit condition is that if boundaries are going out of bounds. So if I is equal to the rows, so I is going to the top and it is gone out of bounds. If I is less than 1, if it has gone out in the bottom, that is I is greater than or equal to m, where m is the number of rows given to us. So if you are taking j as the columns, so if j is less than 0, it has gone out of bounds to the left, or if j has gone out of bounds to the right, So if j is greater than equal to n, where n is the recursive call. If this is the case, we have gone out of bounds, and so we return 1, which represents one of the total way. And if this exit condition is not satisfied, you have to keep making recursive calls on these 4. And you keep track of the count variable and you attach count to every recursive call. And finally you mod it and return it as the output, and implement memoization to avoid repeated calculations. So let's see how we can implement this logic in code. Coming to the function given to us, this is the function name, and these are the input parameters m.n, max move, start row and start column, and the return type is an integer. Like I said, we have to do a recursive call, and that recursive call we're going to return it inside the main method. So I'll name it helper, and we're going to take the same parameters m.n, max move, start row, and the number of moves we are making. And once the number of moves is equal to max move, the recursive calls will end. Let's take m.n, max move, and then start row and start column. And now I'm going to name it moves, and this moves is initially 0, right? And we haven't made any moves as of now, so I create variable moves and pass it as parameters, or directly you can pass this here, that is better. So we start with 0 moves, and I'll remove this. Now let's define this helper function. So it is a private helper function, and it will return an integer because the return type of the main method is an integer, and this should also return an integer. So it is an integer, and let me paste this once, and now all of them are integers. So int m and int n and int max move. And now this is start row, right? So let's use this as I pointer, which will iterate through the rows, and this will be the j pointer, which will iterate through the columns, and 0 is the number of moves, so I'll name it moves. And now this is the recursive call, and inside every recursive call, first we have to define our exit condition. And what will be the exit condition? Whenever the ball is going out of bounds, that recursive call will end. So let us use these pointers. So I pointer, I'm going to check if it has gone out of bounds for the rows. So if I is less than 0, that means I is negative. And now right out of bound is if it has gone past m, so I is greater than equal to m. Now let's do the same for the columns using j pointer. If j is less than 0, it has gone over bounds, and if j is greater than equal to n, it has gone right out of bounds. So this is top out of bound, this is bottom out of bound, this is left out of bound, and this is right out of bound. And in such cases, we will return 1 as the output because we have found one path. So we are returning 1 because we have found one path, because we have to check number of paths whenever the ball is going out. Here the ball is going out, so we return 1 for that recursive call. And now we have to return 0 for the last recursive call when number of moves is equal to max moves. So we stop our iteration. So if number of moves is equal to max moves, we have to return 0 because that is not a path. And now we have to keep counting the total number of paths. So I create a variable count, which is initially 0, calling the recursive call whenever the ball moves in the 4 directions. So this is the first move, and in every recursive call, the first 3 parameters will be the same, and I will keep changing. Let us do I plus 1, and j will be constant, and moves will be incremented by 1 because we are incrementing 1 move. And now we have to apply modulus before adding it to the count, right? So count plus is equal to helper call will be written as count is equal to count plus the helper call, and you can remove the count here, and you can remove the plus sign there. And now to this whole thing we can apply modulus. Now let's repeat the same for the rest of the 3 directions. I'll paste this 3 more times, and here it will be I minus 1 and j, and here in the last 2 I will be constant. We are just moving the column, so this will be j plus 1, and here I will be constant, and here j minus 1. And now we can return count, and before returning count you can again place mod so that the final answer will be decremented. So we are applying mod. Now there are a few typos here. This is max move and this is start column, and we have to declare mod. So I'll declare it globally, and mod value is 10 power 9 plus 7. So this is the mod value. Now let's try to run the code. The sample test cases are being accepted, but all the test cases won't be run, as you'll get a time limit exceeded error because there are a lot of repeated calculations. So let's see how many test cases are being passed. So here you can see you're getting time limit exceeded error, and only 76 of 94 test cases are being passed. Now to avoid repeated calls, you have to implement memoization, and to implement memoization, you have to check how many parameters are being changed inside a recursive call. So the first 3 parameters are being same and last 3 are being different. So we have to store these last 3 parameters inside a array. So let's create a 3D array. I'm going to name it dp. And now here I'm initializing the dp array. So new int. First parameter is m, second parameter is n, and now we have to store the number of moves. And how many number of moves are there? There are max move. So max move plus 1 will be used to store the number of moves. And now we have to fill the dp array with -1s so that we can distinguish if that value has been already been calculated or not. So I'll use 2 nested for loops I and j to iterate through the grid of size m/n. And now we are using arrays.fill to fill the position dp of ij with the value -1. So the entire dp array will be stored with the values -1. And now before making the recursive call, I'm going to check if the position dp of ij and move is not equal to -1. If it is not equal to -1, it means we already have that calculated value. So we can directly return that calculated value. So return dp of ij and move. So this is moves. Let me correct it. And if it is a -1, that means we haven't calculated that value yet. So before returning it, we'll store that value inside the dp array and then return it so that we can use it for the next recursive calls. Now let's try to run the code. The test cases are being accepted. Let's submit the code. And the solution has been accepted. So the time complexity of this approach is O of m/n, where n is the number of moves allowed. And the space complexity is also big O of m/n because we're using a 3D dp array to implement memoization. That's it guys. Thank you for watching and I'll see you in the next video.